Hello everyone, this is R. CHARULATHA from IT Department, Adiparashakti Engineering College. Our IBM project title is Cancer Mortality and Incident Rate Classification Using Machine Learning. I am the team lead for this project and the team members are JANANI, MOONISHAA and SUSHMA S. And the problem statement for our project is to develop a machine learning model to accurately classify the cancer mortality and incident rate based on the various features and data points, aiming to improve the earlier detection and intervention strategies for cancer patients. There are several challenges in accurately measuring and predicting the cancer mortality and incidence rate, including the issues with data quality, imbalanced data, and challenges with feature election and overfitting when using the machine learning algorithm. The problem statement for this project is to develop accurate and reliable method for predicting cancer mortality and incident rate using the machine learning algorithm while addressing these challenges. By doing this, the aim of the project to provide the insight that can help inform public health and intervention aimed at reducing the cancer incidence and mortality rate. The goal of this task to predict the status of cancer incidence and mortality rate based on the set of features.
Problem solution to address the problem of a cancer mortality and incident in classification using ML. The following steps are taken. First one is collect the data set and pre-process it. Second step is to apply various machine learning algorithm and select the model. Third step is to train the model and evaluate it. Fourth step is to test the prediction result of the model and interpret it. Fifth is to continuous improvement, which we have to monitor the performance of the machine learning model. And last step is deployment in integration. In this, we going to integrate and deploy the trained model and develop the user friendly interface for easy access and interpretations for the model prediction.
Technical architecture. Here, in this case, we have collected the data set and we have pre-processed the collected data. After that, the processed data is trained by using the appropriate validation algorithm. Then, it is evaluated and out of the various validation models, the best one is selected. And with the selected model, we will be performing the prediction with the required data provided by the user.
Hello everyone, I'm going to explain about our project workflow and going to demonstrate our project. So before that, let me tell you what tools we have used. So first, we have deployed our project using the IBM Cloud. In that we have used the IBM Watson Studio. Here you can see our project, which is cancer mortality and incidence rate. So basically our project consists of two data sets. One is the death rate dataset and incidence rate dataset. Why? Because our use case is about predicting the incidence rate and mortality rate. So because of that, we have used the two datasets. Here you could see the Jupyter files and their respective CSV files. So we have trained the tested and deployed our project using the IBM Watson Studio. Next, let me demonstrate our project. So here we have saved our Jupyter files, and this folder consists of the dataset, and here we have saved our comparison of incidence rate and death rate individually. And in FLASK, so in static we have images and CSS files and JavaScript files. And here you can see two pickle files. Why? Because we have two predictions. So one is the mortality rate prediction and another one is incidence rate prediction. So because of that, we have saved two pickle files. So let me open this app.py. So I'm using the spider. So this is our code. This is our backend code. So we have integrated using FLASK. So let me run this project. So this is our home page. So we have included some information about cancer mortality and cancer incidence. And below here we have some contact related information. So here in the corner you can see two predictions, which is the predict incidence and predict mortality. So we are going to predict the incidence rate individually and the mortality rate individually. So this is the incidence prediction page. So I'm going to enter some values here. So I've given some values and I'm going to click on this button. So the state is displayed here. It shows that the incidence rate status is stable. So next, let me predict the mortality rate. So this is the mortality rate page. So let me give some values. So I have given some values and let me check this status. So here you could see that the mortality rate status is decreasing. So this is about our project and this is about the project demonstration. Thank you.
Performance metrics are the measure used to evaluate and assess the effectiveness and efficiency of various algorithms. Here we had used 6 different set of algorithms for our model, namely XG Booster, KNN Random Forest, SVM Classifier, Navy Base, and Decision Tree. Out of these various algorithms, we got the different set of train and test score. Among those score, the best algorithm which suits for our model is random forest, with the evaluation value of train score has 1 and the test score has 0.98566.
Future scope. The future scope of cancer mortality and incidence rate should focus on addressing health disparities and promoting health equity. By identifying and analyzing different population groups, healthcare systems can implement policies to improve the access to care. By incorporating detailed patient data, genetic profiling, and molecular characteristics of tumors, healthcare providers can tailor treatment plans to individual patients, leading to improved outcomes and reduced mortality rates. Advancements in data collection, electronic health records, and health informatics can enable real-time monitoring of cancer mortality and incidence rates. This timely information can help in identifying emerging trends, assess the impact of interventions, and guide decision-making process more effectively.
So we finally conclude that this successful development and deployment of this machine learning model can contribute to the advancement of cancer research, prevention, and treatment by enabling healthcare providers to allocate resources effectively and implement proactive measures to reduce cancer related mortality and incidence rates. Thank you all.